This problem and all other Calc 152 problems can be found here at Sarai Studies. Link is in the description box below. Here we have this integral. Let's try doing integration by parts because after all, I do see two things being multiplied together. So integration by part may work. Remember that for every integration by parts problem we do, we will always end up having to do two integrals. So let's do a box and split it into two for the two integrals that we have to do. So here's our box. Now let's get to our formula. So the formula is u minus the integral of v du, where the v's are on the inside. So this is your answer, but you need to find the components that make up your answer. So let's find u. Let's find v, du, and dv. We always start by picking u first. I use limit to help me pick. So I ask myself, are there any logs here? No. Are there any inverse trig? No. Are there any polynomials? No. Are there any exponentials? Yes. So the exponential, I'm going to make my u, and then whatever's left, I make my dv. And then to find v, that's always the first integral that we have to do. So v is always equal to the integral of dv, and we know that dv is equal to cosine of x dx. And then to find the antiderivative of cosine, if you don't remember it, remember sine, cosine, negative, start at the top, down for derivative, d for down, d for derivative, and then opposite way for antiderivative. So if we want cosine, circle cosine, go the opposite way, that's sine. So it's going to be sine of x, and then plus c because this is an indefinite integral because there's no bound. Our v is equal to sine of x. We don't care about the plus c's throughout the process because, again, at the end of the day, if our integral is indefinite, our answer is going to have 1 plus c. And then finally, du is just the derivative of this, which is e to the x, and then don't forget your dx. Your last two should always have d something, and that something should always be the variable that's in your problem. Now we have everything that we need for our formula, so let's go ahead and plug it in. So u is e to the x, then we have v, which is sine of x, minus the integral of v again, which is sine of x, and then times du, and du is e to the x dx. Now this is always the second integral that you have to do. The first is always to find v, and then the second is the one in your formula. So we go ahead and solve that in the second box. So we have the integral of sine of x e to the x dx, and before I do that, I like to actually drop things down so I don't forget anything. So this becomes e to the x sine, and then minus what I get for this integral. I'm going to plug in here, and then plus c, because at the end of the day, I know that because I have an indefinite integral, meaning no bounds, my answer is going to have c. Great. So now I zoom in here, and my strategy is to pretend that I'm seeing this for the first time, like they just gave this to me on an exam. What would I do? Well, I look at this, and this is very similar to this. And if I did integration by parts here, maybe I should try integration by parts here as well. So remember, for every integration by part problem we do, we have to make a box for the two integrals that we have to do. So our formula again is uv minus the integral of v du. We need to find the components that make up our answer, so uv, du, and dv. I always start by picking my u with limit. I ask myself, are there any logs here? No. Any inverse trig? No. Polynomials? No. Exponentials? Yes. So I make my exponential my u, and then whatever is left, which is the sine of x dx, becomes my dv. Then v is always the first integral that we have to do. We put that in the first box. It's always equal to the integral of dv. We know that dv is sine of x dx. And then we would solve the antiderivative for that. Remember, sine, cosine, negative, start at the top, down for derivative, d for down, d for derivative, and the opposite way, this way, for antiderivative. We want the antiderivative of sine, so we go here, we follow this way, that's negative cosine of x, and then plus c because there are no bounds in the integral. Great, so then our v is equal to negative cosine of x. Then du is the derivative of this, which remains e to the x, and then don't forget your dx. Now we have everything that we need to plug into the formula, so let's go ahead and do that. So u is equal to e to the x, v is equal to negative cosine of x. Because this is multiplication, let's just put the negative over here. And then minus the integral of negative cosine of x. So v, this negative goes out here, makes this a positive. And then du is equal to e to the x dx. Now beautiful, this is the second integral that we have to do. So again, for every integration by part problem, we have to do two integrals. One is to find v, and the second is the one in your formula, which is this one. So then I would go and bring this over here, cosine of x, e to the x dx, and I would solve for it and do all that, but you can just notice this is the exact same thing that you started with. And when you see that, you know that you can exit out of here because you're just going to go on forever, because you're going to keep taking the derivative e to the x, which will still be e to the x, and then this will switch from cosine, sine, and whatever sines, and you'll never get out. So what you want to do is you want to recognize that, hey, you have exactly what you started with, so that's an excuse to exit because you can make a relation or literally an equation. So what do I mean? Well, zoom out, right? This integral, we're saying that it's equal to that. Why do we want this integral? Because we needed to plug its answer right here. So this answer, we need to plug it over here. And I'm actually going to make some space. So we're saying it's negative e to the x times cosine of x plus the integral of cosine of x, e to the x, and then dx. And then don't forget the plus c that we had. So this is equal to that. We just didn't simplify because we recognize that this is exactly what we started with. And so what we want to do is make a relation by literally saying, hey, this is equal to that. Like, we know it's equal to that, but write it down. Bring it down. This integral, e to the x cosine of x dx is equal to that. And then let's simplify this a bit. This negative makes this a positive. This negative makes this a negative. So think about this. What's your goal? Your goal is to solve for this. But if we're saying that this is equal to that, guess what? You can literally now solve for it because it's part of an equation. So I want this by itself. Right now it's in two places. I want to get it to one side. So maybe I want to get this to this side, right? So if this is minus, I'll just do the inverse, which is add it. And then these cancel out. But whatever I do to one side, I have to do to the other. So I add it here as well. And just recognize that it is the same thing. The things are flipped, but it doesn't matter. So you can flip it so that it looks exactly the same, like so. And then you recognize, well, you had one of these here, and now you're adding one more. So now you're just gonna have two of these here on this side. But then the thing is, I want to solve for this, not what 2 times that integral is. So how about we just divide? We divide by 2, the 2's go away, and then we divide by 2 here. So we're left with the fact that this integral is equal to this, and then plus the c that's all the way over there. Isn't that beautiful? That is your answer. And that's it for this video. I'll see you in the next.